Assalamu alaikum and very good morning to you. Today in the grade 7 for the subject physics we are going to continue our lesson from the chapter 14, that is more about forces, from the pages 86 and 87. So let's see the learning objectives of today's lesson. We are going to see in the today's discussion that is about the adding forces. In that we are going to see about the adding scalars, adding vectors, parallelogram of forces and the free body forces diagrams. So these all the things which we are going to see in our today's discussion. So let's start with the adding forces. First thing which we talk about the forces, that when anything we are going to move from one place to another place, we need to apply some force on it. For example, in the force there are two things which are very important, and the things which are important, that is, first thing is about the size of the force, and the second thing is the direction of the force. As we are knowing that force is a vector quantity, and the vector of sum of the forces on an object gives a net or resultant force. So here in this picture you can see that the 3 Newton force is on the other side, whereas this is pushing, this is pulling, this is pushing. So the two directions, in the two different directions the force is applied here. To see vector sum of the forces, add the horizontal forces together. That is, if you add 3 Newton and this 3 Newton together, the resultant force, what we say that it is 0, and hence there is no net or resultant force on the mass, and the forces are balanced forces here. The next thing that we are talking is the balanced forces. When two forces acting on an object are equal in size but act opposite in direction, we say that they are balanced forces, and the balanced forces do not change the motion. Here you can see some examples of the balanced forces and unbalanced forces. If there is a force applied here is 60 Newton and 60 Newton from the both sides, the resultant force or the net force will be 0 Newton. Whereas the unbalanced force, where the 20 Newton is applied from one side and on other side 60 Newton force is applied, so the net force which is there, that will be 40 Newton. So opposite force that can cancel each other to equal a net force, and when balanced the net force is 0, as we see here in this. So here balanced and unbalanced forces, if the net force is greater than 0, the forces are unbalanced and the speed or direction will change in the direction of the net force. So here if you see that one is the 3 Newton force and other is 5 Newton force, so net force will be here, that will be 5 minus 3 will be 2 Newton. So resultant force will be here in this picture, what we get, that is the 2 Newton. Furthermore, the resultant of two forces, that will give you the experimental diagram which shows here about the parallelogram. We can see here in the next figure, where the parallelogram of forces, if two forces whose lines of action meet at a point are represented in a magnitude and the direction by the sides of parallelogram drawn from one of its angular points, the resultant is represented in magnitude and direction by the diagonal drawn from that angular point. So you can see that the diagonal, it is drawn here, which is the resultant force which we are getting here, the one force from this side and the other force is from this another side. So this gives you the angular points which are shown here, gives you the parallelogram forces. Furthermore, when you move towards the further part of the lesson where we are going to talk about the free body force diagrams. So here in the free body force diagram, which we see here, that a force diagram, which is also known as the free body force diagram, is a sketch in which all the force vectors acting on an object are drawn with their initial points at the location of the object. So here, if you see the four different directions where the force acting on it is if you are talking about the red arrow, which is showing the friction force, whereas the green arrow which shows you the normal force in the upward direction, and in the downward direction you are going to see here the gravitational force, that is the gravity in the downward direction, whereas in the right hand side if you find that there is a applied force on it, and here is the friction force. So these all the four directions you will get the different kinds of forces here. Also here the same, we can say that the free body diagrams are pictures that shows the size and direction of all forces acting on an object. So here, when the force diagram versus free body diagram, where force diagram shows the forces exerted by the car on other objects, and the free body diagram only shows the car and the forces acting on it. So look at this picture where you are going to see the resultant force. What will be the resultant force here? There are the green arrow, this arrow show that the weight, whereas the yellow arrow showing the driving force in the forward direction, whereas the reaction force is upward direction. You can see here this reaction force. This is the friction, what you see here, and when the car is moving in the forward direction, it is going towards the backward direction, that is the friction. And the air resistance, which we also see in the opposite direction. So be able to interpret situation in which several forces act on an object, and the resultant force on an object is the sum of all the individual forces acting on it, taking their directions into consideration. So all the direction we have to take it into consideration, and from that we can find out the resultant force on it. Here if you see these pictures which shows with the different acceleration, that is the speed of the car, and their force, which is the friction force, we can say the thrust, and the friction force, which we say that also can say the drag vector and the thrust vector. Here car at 10 meters per hour, accelerating quickly because thrust is much greater than drag, so it is moving faster here. And here if you are looking here, car at 30 meters per hour, still accelerating because the thrust is greater than the drag. But in this case, if you see here, the car at 60 meters per hour, where both the forces are equal and hence not accelerating, drag has increased to equal thrust. So there is equal forces, like thrust is equal to this friction force, and where we can say that these kind of things we can observe here. These are the different diagrams which are also showing the same, that is the friction force as well as the driving force on it. And here you can see in the first diagram as well as in the second diagram. In the next picture also you can see here the forces on it with the different diagrams, that is the A, this is the diagram for A, that is the forward force. This is the diagram where you are getting the force as well as the friction in this, and in the another diagram where you are also getting here the force as well as the friction, and here you are going to get the friction only, where there is no forward, there is no backward position is shown here in this diagram. So here with this we can say that the driving force is bigger than the friction force, so the car gets accelerated. In the another picture you can say that the forces are equal, so the car travels at constant speed. But in the picture which is shown here is showing you the driver brakes, so the car slows down and deaccelerates here. So with this we are going to conclude here our lesson, and I'll be back with the new video for the further part of the new lessons. Till then, thank you and goodbye.